Number one in your warm-up, or really there's only one number one, but your warm-up question says, a car starts from rest and accelerates uniformly over a time of 5.21 seconds for a distance of positive 110 meters. Probably should have labeled that as with a displacement of, because I did include a direction there, but let's just go with it. And so you're asked to sketch out the XT, VT, and AT graphs, and then to calculate the acceleration of the car. So let's go ahead and look at the graphs first. And hopefully you've already done this on your paper. If you're answering this in the warm-up assignment, you've got to choose, I think, from the multiple choice options. But whenever you are trying to represent the motion of an object in a graph, you need to ask yourself a couple of questions. And this is what you're going to use as you do today's card sort assignment as well. Okay, same questions I want you to ask yourself. The first thing I want you to ask yourself is this object moving forward, backwards, or is it not moving at all? And then I want you to ask yourself, is this object speeding up, slowing down, or moving at constant velocity? So the first question, which direction is this object going? This particular car, it says, starts from rest and then has a displacement of positive 110, which means it has to be moving forward. Okay, so we need a forward motion for this car. And then the second question, is it speeding up, slowing down, or not, or moving at constant velocity? This particular example is definitely something speeding up because it starts from rest and it's getting faster. So it accelerates from rest. So in this example, we need to represent the motion of an object that is moving forward and getting faster. And so we need to think about what does that look like on an XT graph, and what does that look like on a VT graph? And then we'll deal with the AT in a minute. Okay, on an XT graph, and again, if you have paper out and you don't remember these rules, you probably ought to write it down. But on an XT graph, if you want to show forward motion, that means you need to have a positive slope. Okay, so my XT graph needs to have a positive slope to it. However, because the second question I asked, we said that it's speeding up, that slope has to change because, as a reminder, the slope of your position time graph tells you your velocity. And in this case, I have a changing velocity. So we need a positive slope, but that slope needs to start out horizontal because it says it starts from rest. And it has to then get steeper, but it needs to be positive the whole time. And so the graph should look something like this. However, you don't have to draw your graph from the origin. The question doesn't tell us the position of the car where it starts. So it doesn't have to start at a position of 0, but it does have to have a shape like this. If you drew your graph with the same shape, but drew it starting up here, like halfway up this axis, that would be fine because the question doesn't specify. Okay, so just keep that in mind. Unless they tell you the starting position, we don't know what that is. So in this case, I went ahead and started it at the origin, but you don't have to draw it like that. For my VT graph, again, the same two pieces of information are going to be helpful here. I know this car is going forward. I know it's speeding up. Okay, going forward on a VT graph means that I need to be plotting my points, drawing my line in the positive region of the graph above the x-axis. The fact that it is getting faster, it's speeding up, means that that velocity needs to be changing. So it's not going to be a horizontal line. It needs to be changing uniformly, so the same amount each second. Okay, and it needs to be getting faster, which means it needs to move away from 0. So it's going to look something like this. Now this graph does have to start at the origin, because it specifically says a car starts from rest, which means its initial velocity has to be 0. So this one has to start at 0. It needs to have a positive slope and be in the positive region of the graph to show that it's speeding up while moving forward. Now, the AT. The AT graph is not something I would try to draw from reading that scenario because acceleration time graphs are hard to draw if you're just looking at an XT graph or if you're reading a scenario like this. However, they're really easy to draw if you just look at your VT graph. So after you have a VT graph in front of you, then you can match it to the AT graph really easily. Because, again, as a reminder, and if you're taking notes, you might want to add this back down. You should already have it from last week. But as a reminder, the slope of a velocity time graph tells you your acceleration. So all you have to do is look at your VT graph and ask yourself, is this a positive slope, a negative slope, or a slope of 0? So looking at my VT graph, is that positive, negative, or 0? It's positive. I don't have numbers, but I know it's positive. And so that means my acceleration is positive, and my acceleration is uniform. It's the same the whole time. Okay, so maybe the slope of this is positive 3. Well, then guess what? This is positive 3 meters per second each second. All right, so these are the graphs that you should have sketched on your paper and that you should be choosing in the assignment for your warm-up today. Let's go ahead and do the math portion of this warm-up question. Calculate the acceleration of the car. Again, anytime you are doing a calculation problem, we're going to go through, or at least I'm going to recommend that you go through, the guess method. Go through the steps of labeling your givens, labeling your unknown, choosing your equation, substituting, and solving. Okay, if you go through that problem-solving process, you are a lot less likely to make a mistake. So, given information, that's the G. I know that this car starts from rest. Again, that is a piece of information that's given to me. I know it's not a number in the question, but if you see starts from rest, if you see comes to a stop, if you see words that indicate what your object is doing or that it's not moving, that is a piece of given information. In this case, it started from rest, so its initial velocity is 0 meters per second. The next piece of information I see is a number, a time of 5.21 seconds. So I know my time is 5.21 seconds. And then I have a displacement of positive 110 meters. That's all in the question. The unknown, what I'm being asked to find, is calculate the acceleration of the car. Therefore, my unknown is acceleration. You want to label that too because you can't solve for it if it's not in the equation that you choose. And that's your next step, is to pick the appropriate equation. Looking at the 4 equations on my screen, A, B, C, and D, which of these equations allows me to solve for acceleration with the information that I have? C. Now, I had somebody last period asked, well, why does it have to be C? And if you haven't figured this out yet, I don't know final velocity, which means I can't use equation A or equation B because I don't have VF. And I don't have A. And so I have 2 unknowns in those 2 equations. I could use equation D and find VF and then find A. Okay, but you only have 2 options here. You could either use equation C to solve for A directly, or you could use equation D, but you can't solve for acceleration in equation D because it's not there. If you use equation D, you'd be solving for VF, and then that's the second step where you then still have to solve for acceleration. There's only one equation that you can use to solve this in one step, and that is this one. Delta x equals VIT plus 1/2 AT squared. So that's what we're going to substitute into, and that is the next step in our guess method, is substitution. So I put all my numbers in. 110 equals 0 times 5.21. plus 1/2 times A times 5.21 squared. 0 times 5.21 is just 0. This is my solution step. Now we're doing the math. 0 plus 1/2 A times 5.21 squared is 27.1441. You don't have to write all the steps, but I'm going to go ahead and do it so you can see where I'm getting it from. By the way, if you end up with something like this where you're adding 0, you can just cross that out because we don't need to type plus 0 in a calculator. We all know that that's not going to do anything. Okay, and so now we have this. 110 equals 1/2 A times 27.1441. So half of 27.1441 is that value, 13.57205. Again, your whole goal here is to isolate your variable, get A by itself, and so your next step needs to be dividing both sides by 13.57205. That's what goes in your calculator, 110 divided by that number, and that gives you this as your acceleration, 8.10 meters per second, which could also be written as meters per second squared. Are there any questions about this calculation? Okay. Then let's go ahead and, as I said, we're going to take some notes over some graphs because this right here is basically what you're doing in the card sort. Okay, I'm going to, again, encourage you to copy this stuff down. Okay, if you've got a phone out, they should not be out right now, put them up. But you need to go ahead and copy down the graphs that we have here. Okay, so I've drawn one graph on the screen for you. Your task is to draw the other two graphs that show the same motion. So you have a VT graph for this one. I need you guys to figure out what the XT and AT graphs might look like. If you can sketch them, then you can match them in a minute. Okay, and that means that you can also theoretically do well on the free response part of your test on Friday. Okay, so again, take a moment. I'm going to give you, let's say, 34 seconds to try this one. You can talk to your neighbor if you're not sure, but see if you can draw an XT graph and an AT graph that show the same motion. You have 34 seconds. Okay, so I mentioned this already, but these are the two questions I want you to ask yourself. Which direction is this object going? That's the first one. So is this object going forward, backwards, or is it not moving? Let's start there. Forward. This object is moving forward, and I know that because it's in the positive region of my VT graph. It has a positive velocity the whole time. That's forward. Second question. Is this object speeding up, slowing down, or does it have constant velocity? This object is speeding up. So you need to represent an object that is moving forward and speeding up, which sounds familiar because that's basically what the warm-up was. So it's going to look pretty similar to the warm-up with one minor difference, and that is the fact that this particular object isn't starting from rest. It has a y-intercept that's a positive value. So it's not going to be completely horizontal at the beginning, but it is still gonna have a similar shape. It has a little bit of a slope here, okay? But it's the similar shape. And again, I have no idea what my y-intercept should be on my XT graph because I don't know what my starting position is. You cannot tell that by looking at that VT graph, okay? The VT graph does not give you that information. So you could have drawn this at 0. You could have drawn it here. You could have drawn it up here. As long as you have the same shape that I do, you're good, okay? So that is what the XT graph should look like. The AT graph. Again, your AT graph is really easy to draw if you just look at your VT graph. What is the slope of my VT graph? Positive, negative, or 0? Positive. And again, the slope of a VT graph is your acceleration, so I need a positive acceleration. Okay, if I had numbers on here, maybe I would call this +4, in which case this would be at +4. But I don't have any numbers, so we're just looking at shape. All right, so that's the first one. Let's try another one. This time I gave you an XT graph. I want you to do the same thing though. See if you can sketch out the VT graph and the AT graph that show the same motion as this XT graph. I'll give you 31 seconds this time. Go ahead and see if you can sketch those or turn and talk to your neighbor about what those graphs look like. You have 31 seconds to discuss. All right, so again, two questions. Let's start with the first one. Is this object moving forward, backward, or not moving at all? Yeah. And again, guys, y'all should be listening, answering these questions with us. But yes, somebody said backward. That is correct. Okay, it is moving backward. Again, on an XT graph, my slope tells me my velocity, and the fact is I have a negative slope here. It's changing, though, which leads us into the second question. Is this object speeding up, slowing down, or is it moving at constant velocity? I know it's not constant velocity because I know my slope is changing. So in other words, is this speeding up or slowing down? slowing down. And I know that because it's getting less steep. In fact, it looks pretty horizontal at the end, which means it theoretically came to a stop. Okay, so I need an object that is moving backwards and slowing down. How do I show that on a VT graph? Again, backwards on a VT graph means I have a negative velocity. That means I'm going to be drawing this below my x-axis. Slowing down means that my velocities are getting closer and closer and closer to 0, because if I reach 0, I have stopped. And this one does look like it stopped. It looks pretty horizontal, so my graph would look something like that. Okay, I have a backward motion because I'm down here and it's getting all the way to 0. It comes to a stop at the end. All right, AT graph. Again, all you want to do for this one is look at your VT graph. Is the slope of my VT graph positive, negative, or 0? Come on, guys. What's the slope? Positive, negative, or 0? I hear negative and I hear positive. One of those is right. This is a positive slope. Yes, it's in the negative part of the graph. That's not what I'm asking. I'm asking about the slope. This is a positive slope, and therefore it is positive acceleration. Okay, so again, negative slope would have been something going down, like this was negative, this one's positive. All right, so positive slope means positive acceleration. All right, try this one. Here's a VT graph. See if you can sketch out a matching XT graph and a matching AT graph. This time I'm going to give you 27 seconds. Go ahead and try that, or turn and talk to your neighbor. See if you can figure out what it would look like. You have 27 seconds. All right. So again, first question, is this object moving forward, backward, or not at all? I heard an answer over there.
Backwards.
It is backwards. Okay, I heard earlier somebody told me not at all. This is a VT graph. This is moving. I don't know, again, I don't have numbers, but -4, whatever, it's moving. Okay, so this is moving backwards. Is it, or does it have constant velocity, or is it speeding up or slowing down? Constant. It's the same thing the whole time. So if you want to show something that is moving backwards with constant velocity on an XT graph, backwards just means negative slope. Constant velocity means my slope should not change because I'm not speeding up or slowing down, and my slope again is my velocity, so I want my slope to be constant. Something like this. Again, you could have drawn it starting farther up here or lower down here, so long as you had a straight line with a negative slope. Okay, it should look something like this, but we don't know exactly where to start. We cannot see that on our VT graph. All right, AT graph. Again, look at the slope of your VT graph. The slope of your VT graph tells you your acceleration. Guys, what is the slope of a horizontal line? 0, which means we have 0 acceleration. If you want to show acceleration of 0, you're going to be drawing that at a equals 0. That's your y-intercept, or your a-intercept here is going to be at 0. So this is 0 acceleration, looks like this. I got one more, and then you're going to be working on your assignment. All right, draw the graphs for an object moving forward and slowing down. This time I didn't give you a graph, I just gave you a scenario. You should still be able to do it though. Go ahead and draw what the XT, VT, and AT graphs would look like for an object that is moving forward and slowing down. I'm going to give you 36 seconds this time because you got 3 of them to draw. So go ahead and draw those. Turn and talk to your neighbor if you're not sure. You have 36 seconds to discuss. Okay, so we already answered my 2 questions, because I normally ask which way, and then is it speeding up, slowing down, or constant velocity, and we already know both of those. Forward, slowing down. So that makes it easier. We already have it. Look at your XT graph. Forward means positive slope. Slowing down means my slope needs to get less steep, because steeper means faster, slowing down means less steep. So it needs to look something like this. Again, you do not have to start at the origin. It doesn't tell me where to start. So you could have put this with a y-intercept and had it starting up here. It doesn't matter. All right, my VT graph. To show something is moving forward, I need it to be in the positive region of my graph above my x-axis. To show it is slowing down, I need it to get closer and closer to 0. I don't want to cross the x-axis because that would mean it turned around and it doesn't say that it did that. Okay, so something like this, I didn't quite slow to a stop because I didn't quite reach the x-axis, but you can see here this object is forward the whole time and it is approaching 0. And again, that is what you should have on your graph as well. All right, for the AT graph, again, the slope of your VT graph gives you acceleration. Is this a positive, negative, or 0 slope? Negative, so I have negative acceleration. That's all you're doing, okay? So if you can go through that same thought process, that's exactly what you need to do as you work on this assignment, 204 acceleration card sort. If you are not already in Schoology, please make your way there and open up this assignment. It is a Google Sheet. When you open up the Google Sheet, you're going to type in your student ID. It gives you a link to Desmos, which you're going to follow to do the Get Desmos card sort. And then you're going to come back to the Google Sheet after you've done the card sort in order to answer the questions. Okay, now I will say this. You're going to be grouping these into sets of 3, XT, VT, and AT graphs. However, you are missing 2 graphs, and that is on purpose. When you try to make your sets, 2 of your sets are not going to have a 3rd graph. There is one that's missing an XT graph, and there is one that's missing a VT graph. And so you're going to have 2 sets of 2, and everything else is going to be complete. When you take your card sort quiz, it's going to ask you, hey, which one was missing this graph? Okay, or what does this graph look like? So you will see questions about it, but that was done intentionally. Okay, so again, make your way to Schoology. Use the link to go to Desmos first. You do need to do the card sort, otherwise you're not going to know which one was missing a graph or be able to answer all the questions. Okay, so do the card sort first, and then you can check it up on my screen. I'll put that up there in a second, so you can open it up to see how you did. And then you can go back and answer the questions. If you do finish early, you're welcome to work on the unit summary in Schoology, because as a reminder, you guys have a test on Friday of this week, and you have a quiz on Wednesday. If you have questions as you're working, let me know. You are welcome to work with your neighbor. That is perfectly fine. I encourage you to work together. You are going to get different questions at the end, though, but you're more than welcome to help each other out on the card sort.